In this lecture, we're going to introduce the ability to run in parallel on our behavior tree. This will allow us to design our behavior of our workers in the tree while they're building, without having to put all of that logic into a single node. If we start over here in the behavior tree for the worker, we can think about how do we want our agent to behave while they're building. And sure, we could build a lot of that logic into this node. Self-builds building SO at target location, and that does all the animation and picking a location to move to and all that stuff. That's a totally viable option. That does make this one action do a lot of things, which may not be the best long-term solution. If we wanted to, we could define that behavior outside of this node and put it into the graph. Let's take this node, break it out of our sequence. Same with setting the command. We'll build a new sequence on the left side here. If we want the behavior tree in this graph to do more than one thing at a time, we can drag from this top sequence, just drop into the empty space, come to flow, and we have something called parallel execution. If we click on that, we've got this run in parallel, which will execute all of the branches underneath that. We're only going to have 2, but you could have as many as you like, and run all of those at the same time. That's a slight misnomer here because it's not using different threads or the job system or anything like that. It's just going to run this one and the other one, and they're both going to execute on the main thread. It's just not going to only be running this one aspect of the tree. If we zoom out, the rest of the tree is working where it's going to only do one thing at a time. We'll go down one particular branch until we hit the end, come back up to the top, and then maybe execute down a different path. With this one, we're going to enter in from build building, come down, then run 2 sub branches. We can hook that straight up into our left sequence over here. We know we're going to want to do that. Then on the right side, we want to handle some animation. And we're just going to explore some different aspects of what we can do here in the tree. This may not necessarily be the best design, but it's a good way to show different ways we can structure doing the same type of thing. If we right click, add, and go to sticky note, we can write ourselves some notes and conceptualize what we want to do before we add in the specific nodes. The first thing we'll do is wait for some time. We don't want it to be very jerky whenever they just get there, they start moving. So we'll wait for some specified period of time. We copy paste that sticky note. The second thing we want to do is pick a random location within the bounds of the building being built. And then we can paste again. Step 3, move to that target location. And then of course, this may need to happen more than once because maybe this only happens, let's say in 6 seconds, and it takes a minute to build our building. Then we'd want to keep repeating this until that minute expired, right? And we can conceptualize this 2 different ways. The classic way we may think about it is just to make a sequence, just like what we did, wait for some time, pick a random location, move to this, straight down, top down. Just like what we see over here on the left. That's not always the easiest or most convenient way to do things, so we're going to introduce a new concept here. In addition to our run in parallel, if we just press space, again flow, there's something called try in order, which will execute each branch until one of them succeeds. This allows us to conceptualize these as 3 different branches side by side instead of a top-down sequence. And of course, we're also going to want to add in a repeat node. So again, space, flow, repeat. And if we go over to the inspector, we can repeat forever until success, fail, or on a specific condition. Just for fun, let's add the condition. And this works the exact same as what we've seen before. Like we have our abort if. We've got this branch on a condition. All of these work the same. In our repeat while, we could say we want to repeat if any are true, assign condition, a new variable condition, variable comparison. Maybe if the command is equal to build building, for example, we would want to keep doing this stuff. It's a little bit redundant because we know we're going to come in here, but that just shows how we can set up these different conditions. Let's just hook this up into our larger graph now, run in parallel into the repeat while into the try in order. Keep in mind that this is going to do until one succeeds. The first thing we want to do is wait. So let's add in a new node, wait. We can wait for a constant 5 seconds. But now this is going to succeed after that 5 seconds. So if we hook try in order into this, we're always going to stop here. We're not going to do any of the other ones because this will succeed. So if we say wait for 5 seconds, drag down out of that and look for something called an inverter. Because this top one succeeded, this one will now make it fail, which will allow us to go into our next branch. And we need a new node to do this, pick a random location within the bounds. That's not something built in. And to move to a target location, we don't want to move with the NavMesh agent because we do know that we're eventually going to be carving the NavMesh where this building is placed. So we need to move without a NavMesh agent. So that's also going to be a new node we have to build. So let's make these two new nodes. Just space, action, create new action. We'll call it pick random location within renderer bounds, which is a little bit verbose. And let's just leave that in the default action category. Click next. And what type of story do you think we should put in here? Maybe set target location to a random point within building under construction, where target location is a vector 3 and building under construction is a base building. We have to change the type of that building under construction to base building. Then we can click create. Put that in our scripts, behavior, save that. And that'll take us over to VS Code, but I don't want to go there yet. We're going to need to know this building under construction. And this action actually already knows that building. We're just not publishing it to the Blackboard. So on our Blackboard, we can add a new base building. Let's call it building under construction. And that tells us that this node, self-builds building SO at target location, is going to need somehow to hook this up. So we're going to need to change something in there. Then that'll set it up so this node will have something to work with. Drag the building under construction to our set target location node. And then let's make our new move to target location, space, action, create new action. For this one, let's call it translate position and put that in action/navigation. For the story here, what do you think it should be? I think something like self moves to target location at speed, where the capital speed can be a basic type, float. Target location is vector 3 and self is a game object. Perfect. Create. Again, in our script's behavior. And I think we're ready to come over to VS Code. Let's start with our build building action. We need to attach a serialized reference, public Blackboard variable of type base building. Call it building under construction. Anything that is not marked with serialized reference will not persist the value into the Blackboard, which will give us weird errors where it looks like everything is working right until you try to use that value in another node. And in here, right after we get that component on the base building, let's just assign that. Building under construction.value equals the completed building. That's all for now in here. Let's come over to our pick random location within renderer bounds action, which is a mouthful. Move that into our namespace, GameDevTV RTS behavior. We don't need to do anything on update or end here, so let's remove those. On start, we can check if the building under construction value is null. If so, just return a failure. Otherwise, we can get the bounds off the renderer here. We can do render equals building under construction.value.main renderer. We can check if the renderer is null here, and if so, also return a failure because we can't process this if for any reason that main renderer wasn't assigned. Then we get the bounds equals render.bounds, and we can override our target location value. So we're going to post a new value to the Blackboard with target location.value equals a new vector 3. And we're going to want to keep the y value the same. Wherever this was placed is the right y value. We're just going to move around on the x and the z plane. So we can do, for the x value, a unityengine.random.range between the bounds.min.x and the bounds.max.x. Keep that target location value y, and do the same thing we did for the x on the z with unityengine random range between bounds.min.z and bounds.max.z. And then finally return a success. And I don't love that we've got two if checks here. Why don't we move that check up to the top if? So if the building under construction value is null, or the building under construction value main render is null, or return a failure, that lets us be safe and keep our code beneath that a little bit more clean. So we can see that there's sometimes the case where we can misconfigure something in the Unity editor. In this case, we could have not assigned the main renderer in the editor, and this node would stop working. We have some of those cases handled in build building action, but not all of them. And for this lecture's challenge, I'd like you to, in the build building action, ensure that we don't run into any null reference exception if we've misconfigured any objects in the Unity editor, just like what we did on that other action. Return a status failure if there's any misconfiguration. So pause the video, analyze that code, find out where we're going to run into a problem, because I promise you we can, and I'll see you back here in a few minutes. All right, welcome back. The easiest way to check for this is just to imagine if that value is null, what happens. We've already made sure in hasValidInputs that self is not null, building SO value is not null, and the building SO prefab is not null. So we're sure through here we're safe. Instantiate won't return a null instance, so we're okay there. But on this line, it's possible that we don't have a building. And it's also possible that our building didn't get a render assigned, because this prefab is just a game object. We could assign any type of game object. It doesn't have to have a building, which means that this line here could give us a null-based building, which means we get an exception thrown on this line. Instead of doing just a straight get component, we can do if not building.tryGetComponent out completed building, return status failure. Then we know we've aborted execution at that line before we try to get this main renderer. But remember, also our completed building main renderer may be null, so we can just add in an or completed building.mainRender is null, return that failure. Now we know we're safe here on line 34. If we keep going down, building under construction value, we're assigning the value, so that's okay. And that's the end of where we're trying to reference any objects. That's all we were looking for. I hope you're able to get that on your own and can see how we can analyze our code, see where we can run into problems, and prevent them before we run into them. Let's come back into Unity in our worker behavior tree. And in here are self builds building SO. At target location, we need to assign that building under construction. Just link that building under construction from the Blackboard. Let's hook up our try and order to the set target location to random point node. So we're going to wait for 5 seconds, then we're going to pick a random location. We haven't implemented this node yet, and I think getting into that might take us a little bit too long. Let's just put that here on the side, but we still want to move. So let's take try and order out to a new action, navigation. We'll use the built-in navigate to location, provide self and the target location. This has some other configuration. For now, we'll just leave all of that alone. I think it's going to be okay. And remember, try and order wants until 1 succeeds. So our set target location, we need to go to an inverter again. So now we'll come in here, we'll wait for 5 seconds, we'll pick a location, and then we'll move to that location. Let's save that. In our project panel, if we come to our command post, build time's right now only 5. Let's go ahead and move that up to 60 so we can actually see our worker move around. Let's click play. Select a worker, tell them to build the command post. They'll wait for 5 seconds, pick a location, move to that, and we'll see this building starts creeping up out of the ground. And every 5 seconds, they'll pick a new location and just move to there. But they're not animated, they're just standing there, and then this building's coming up, so it doesn't look very good. In the next lecture, we're going to see how we can improve our behavior tree to add in those animations and maybe do something with our material so we can still see our worker. Because right now you can see there's no worker there, or at least we can't see the worker. When you're ready to work on that, I'll see you on the next lecture.